Hey everyone, my name is Harun, and today on my channel we're going to be talking about ratios, specifically an introduction to ratios. Now, we need to understand what a ratio is until we can solve them. So that is the key question for today. What is a ratio? Now, a ratio can be defined as an accordance between two things that are not similar. For instance, circles to squares. Circles and squares are not similar, they are different things. Therefore, a ratio shows the accordance between each of these, or red to blue, or triangles to squares. But before we get into those, please take a moment and subscribe to my YouTube channel and show the like and support for all my videos. Without further ado, let's get started. So, here on our first example, we have ratio of circles to squares, right? And here we have our circles and squares. So let's go ahead and count them. 1, 2, 3, 4, 5 circles and 3 squares. Now, two ways to write a ratio. You can either write it, and I'm going to put it up here, either 5 to the word, literally the word 2, write it as you see it, 5 to 3, or 5 dot dot 3. And those are two ways. Either one is fine, no specific preference. Okay, so here now the way to write the answer, okay, correctly is a lot of students think that you put the bigger number on the front, a smaller number right beside it. That is not true. You have to look at the question. What does the question ask you to see the accordance to? Circles to squares, right? So as circles comes first, circles will be our first. So circles are 5, so we're going to put 5. And then to squares, which shows the accordance of circles to squares. Now we can check that by simply counting them. Pretty straightforward. Okay, so let's go on to 2. Ratio of red to blue. Okay, so let's count our red and blues. So we have 1, 2, 3, 4, 5 reds, and 1, 2, 3, 4, 5 blues. Now, here we have two of the same numbers, right? So let's go ahead and write our answer. Okay. And remember, we're showing the accordance of red to blue, not blue to red. So, the thing with ratios is they're actually pretty similar to fractions to a certain degree. You cannot multiply ratios, or paradoxically you could, but how they're similar is that you can simplify them. So, remember, a ratio is an accordance between two different things. So, this shows that for every 5 reds, we get 5 blues, right? So we can simplify that. We can say, and this would be true for every one red, you get 1 blue, and then for every, let's say, 2 reds, you get 2 blues, and so forth and so on, right? So we can simplify this and say that this is a 1-to-1 ratio. Now, when you do this on, let's say, your homework or classwork or something, it might say simplify, might not say simplify. You can go ahead and do either or. It really doesn't matter, but it's still the same thing. It's equivalent. It's the same. Okay, and our last explanation for today, ratio of triangles to squares, right? So we have 1, 2, 3, 4 triangles, and then 1, 2 squares. So let's go ahead and show our accordance of triangles to squares by doing just that and writing 4 to 2. Now remember, like we did in the previous one, we can simplify, right? So we see that for every 2 triangles, there's 1 square, and same here. Every 2 triangles gets 1 square. So let's go ahead and write this is a 2-to-1 ratio, okay? Because for every 4 triangles, you get 2 squares. So we can basically say that for every 2 triangles, you get 1 square, and that shows how it is right. Thanks for watching, ladies and gentlemen, and until next time, I'm Harun.